all you're doing is the domain. So number 3, what did you get? Negative infinity to infinity or all real numbers. How about number 4? Negative infinity to 3, that's an asymptote. Now, number 7, it's kind of hard to tell if that's an asymptote or not. So if you called it an asymptote, then you would do from 5 to infinity. If not, then it would be all real numbers. That's what I meant, negative 5. So sometimes it's a little bit hard to tell, but if it's a graph, if your explanation makes sense by looking at the graph, then I'm not going to be too strict on that. What about if we were given a function? Let's say the function x plus 1. What would the domain of that be? All real numbers. How come? Well, we're looking at the numbers that I'm allowed to plug in. If I graphed it, it would be a straight line, which a slanted straight line, which is all real numbers. But when am I not allowed to plug something in? Can you think of an instance where you plug in a real number and you have a function that creates a non-real number? Negative square roots, right. If I had the square root of x, that would be a problem. Because I plug in 4 and I get 2, I plug in negative 4 and I get 2i. And 2i, while that number exists, it's not a number that can be graphed on a real number line. So it's an input without an output, therefore it's not part of the domain. So if I had a different square root, say the square root of 2x minus 8, what numbers am I allowed to plug in and which ones am I not allowed to plug in? Any negative number is going to be a problem. Are there any positive numbers that are also a problem? Okay, so we could say everything below 4, and we're talking about the domain, so we want to talk about numbers that do work. So all you have to do is say this needs to be 0 or bigger. Everybody agrees? Because the square root of 0 is 0, and that's fine. So I'm just going to say 2x minus 8 is greater than or equal to 0. And then just solve for x. Add 8, divide by 2, and I get x is greater than or equal to 4. And that's the domain. So as long as x is 4 or bigger, then the graph will exist. All right? Well, what if we have one that's really complicated? You guys are going to love this. Don't write this down. 3 square root of 6x plus 1. Let's divide that by 5 and then add 1. And I'm going to, squaring it's probably a bad idea. Okay, so what's the domain of that? Well, the only thing I care about is the square root of negative numbers. So I can ignore everything there except the square root. So if I look here, I want to know when is 6x plus 1 bigger than or equal to 0. As long as that's true, I'm okay. So I solve for x, and I get x is greater than or equal to negative 1 over 6. And I don't care what the graph looks like. The only rule I have to be careful about is if I plug in a number, do I get an I? In which case the graph doesn't exist at that point. Does that make sense? There's one other time when you create a non-real number, and we've already done it a couple days ago. Rational functions. When else can you plug in a number and get a non-real number? Look at number 1 on page 100. What sort of function, or how come 4 and negative 4 don't exist on number 1? They're vertical asymptotes. And where do vertical asymptotes come from? Oh, come on. What's wrong with that? Dividing by 0. If I divide by 0, then I get a non-real number. So in this case, x equals 3, which is from this factor, represents what? A vertical asymptote. And x equals -1, which comes from that factor, represents a hole. But in both cases, the domain doesn't exist. So the domain of this is all real numbers, but x is not allowed to be 3 or -1 because we're dividing by 0. Are you a train robber? Our friends at home are going to love that random comment. They'll wonder who I'm talking to. So who's not here? Lexi? Lexi, when you hear this... Okay. So the only two things that will restrict the domain of a function is dividing by 0 and square rooting a negative number. Everything else doesn't matter. Okay? Well, it is a little bit tricky sometimes. Will that create i's? No. Third roots do not. So the domain of this would be all real numbers, because I don't have a square root that has negative numbers, and I'm never dividing by 0, so that would be all real numbers. What if I change that 3 to a 4? Then I need to restrict the domain. So in this case, x would be greater than or equal to -1. Because even roots do create i's, odd roots do not. So if you have a problem with an odd root, it's all real numbers, unless there's some dividing by 0. So if you had something really crazy like 5 square root of 2x minus 4 over x, and it doesn't matter what else you do, times 12, it doesn't matter. Okay? So I know that x is not allowed to be 0. So x cannot equal 0. And I also know that this needs to be greater than or equal to 0. So I'm going to add 4. So x is greater than or equal to 2, in which case I didn't even need to worry about that, right? This didn't even matter because it's not within there. But if that 4 would have been positive, then I would have subtracted 4, and I would have got x is greater than or equal to -2. I would have need to said x is greater than or equal to 2, but x is not allowed to be 0. So on the rest of page 100, all you're going to do is look through there and decide what values of x do not count. And all you're looking for is square rooting negative numbers and dividing by 0. If it doesn't have those two problems, then it's going to be all real numbers. Now, number 12, we're kind of cheating. We haven't taught you number 12 yet, so skip it. Don't do number 12. And 15 looks tough, but does 15 ever divide by 0? No. Is there a square root in there? No, so the answer would be all real numbers. So I'll give you just a minute to go through that, and then we're going to talk about page 96.